Good day, everyone. I am Romieleth Espillardo from the Astrophysics major, and together with my partner, Angel Luarenz Garcia, we are now going to present our study entitled Assessment of the Damaging Effects of Galactic Cosmic Radiation or GCR-Induced Hepatic Injury in Mice.
As time passes by, our civilization grows and new technologies also appears. Soon, space exploration beyond the galaxies might be possible. However, there are limitations and restrictions that we may face, such as long-term food supplies and bodily functions. We all know life on planet Earth are not designed to absorb and be exposed from galactic cosmic radiation, and one of the major organs that is highly affected and damaged is the liver. In 2020, Simonson stated that the threat of galactic cosmic radiation lies within the health of astronauts partaking an expedition through outer space. In this study, we uncovered the damaging effects of galactic cosmic radiation in a mice's liver.
With that, we have utilized the data from mice specimens from the experiment conducted by NASA during the SpaceX 4 mission. As for the statement of the problem, the primary goal of the study is to assess the degree of damage of GCR to the liver of the mice. The damage degrees are assessed per session type in the mission, namely basal session type, vivarium session type, ground control session type, and spaceflight session type. There are three parameters used to assess this damage. Firstly is the presence of fibrous septa. Second is the presence of nodules. And finally, quality changes in periportal and pericentral zones. And for the last part of SOP, the study is driven to conclude what are the effects of GCR to the hepatic cells of mice. For the research methodology, firstly, we have gathered our data from database platforms of NASA. Firstly is the Open Science Data Repository or OSDR. It is a web-based platform that has space-related studies, specifically on how the terrestrial biology adapts to the space flight environment. Furthermore, we used another database platform from NASA, which is GeneLab. It is a library for open science multi-omics. The data that has been gathered from the NASA database platforms consisted of digital slides. These digital slides were then assessed by a veterinary pathologist from the University of the Philippines, Los Baños, namely Dr. Maria Susanette Lola. She made a pathology report for the digital slides, and then this pathology report then underwent for data extraction by us, the researchers, in order to make a coding manual for statistical treatment of the data. For the statistical treatment of data, we have used tests that are recommended by our biostatistician, Mario B. Prado Jr. from the University of the Philippines. The main test that we use is the one-way analysis of variance or ANOVA. It is used since the data from the samples were deemed of equal variances. Also, it is used to see any statistical differences among three or more different groups. As we have used different and various parameters, we also employed follow-up tests after ANOVA, which are Sheffield tests and Tukey test. Sheffield test is used to assess the varying mean scores of treatment groups, while Tukey test is used to identify which group is statistically different from the others. Lastly, we have also used the Fisher's exact test to find the non-random relationships between two category variables.
As shown within the pathology report created, there is no difference within the severity of septa towards the session types. While ground control and vivarium session types have been the most affected within the assessment of severity of hepatocellular lytic necrosis. It was also revealed that ground control session type has the highest severity of hepatocellular lytic lesion condition amongst the other session types. The assessment of perivasculitis shows that session types had two different results, which are widespread for spaceflight and ground control, followed by basal and vivarium session types for multifocal. It is also shown that vivarium and ground control has the highest hepatocellular vacuolar fatty degeneration. It is concluded that galactic cosmic radiation has significant damage throughout all the session types, namely basal, vivarium, ground control, and spaceflight. Presence of fibrous septa is also noticed without nodules. There is a range of normal to moderate to severe hepatocellular lytic necrosis that happened. The condition of hepatocellular lytic lesion have been categorized into path and coalescing, and widespread, followed by perivasculitis, which is grouped into two, multifocal and widespread. Lastly, the range of normal to moderate to severe hepatocellular vacuolar fatty degeneration have been noticed. Based on the study's findings and conclusions, the researchers would like to recommend the following. For the first recommendation, if possible, future researchers may opt on obtaining the physical slides for the biospecimens, since these digital slides limit the parameters for assessment and observation. For the second recommendation, biospecimen staining can also affect the observable parameters. In the case of visualizing the Kupffer cells, which are the liver macrophages, a special stain like F480 is necessary. And for the last recommendation, the researchers suggest considering other sampling schemes that can help give a higher number of samples.
And that concludes our presentation. Thank you so much for listening.